Yeah, I know they've stopped it. Can't do it, she starts sometimes.
Okay, so here's a few problems that we'll go back to this number 4 in a slower fashion than what I was doing the other day. So when I was trying to throw it in, there's so much important happening here between the domain that they give you that you should stay in and so on. All right, so we had f of x is equal to 2 sine x plus cosine 2x. And I'll get rid of the background for right now just so you can see this important work and I won't have to fight with it. Let's see. There we go. No, it's like a watermark. Okay. Really pay attention and stay within the domain that they give you. It's like a gift, all right? We don't have to do a 2 o'clock K thing or anything. One thing that a couple of people saw with me in the last couple of days in working problems together is the phenomenal hidden behavior that you can find from first and second derivatives, where you really can bank on them more than what you see in your math and calculator, but everything will show up. All right, so my first derivative is 2 cosine x. Don't forget the chain rule. The derivative of cosine of anything is negative sine of that thing. Okay, so that's negative sine of 2x. And then you come back and uncover it and take the derivative of what's underneath it, which is 2. All right, then if you had a calculator, something that we've worked on in my class some now, especially that I would feel like I could ask you on a test given the last video and the last test where it was sensitive so far to calculator active problems. In this case, if you had a calculator, I wouldn't even take the derivative. I wouldn't even risk that. It was a calculator active problem. I would put this in y1. It seemed like y'all were doing really good at that the other day when we were practicing it together. I wouldn't even take the derivative and risk a mistake with a chain rule or a sign. I put the original in. You know how you can turn it off? Make your calculator give you a graph of the derivative, girls. I would change my window from 0 to 2 pi. Only look at, maybe give yourself a little edge, on either side. But you're only looking on 0 to 2 pi, so don't get this big crazy sine curve. You can also shrink it down to like negative 3 to 3 probably, maybe negative 5 to 5, because this can't go very far. It may go almost as high as 4 because those 2's might get added together at different intervals. Do y'all see what I mean? At different values, there's a possibility the highest it could go is 4. But then you would see where your derivative is positive, where your derivative is 0, and you could go forward with that. Then how could you take the second derivative on your calculator? I would turn the first and the second one off and go to y3 and take the derivative of y2. It is a way to take the derivative of the original, the second derivative, but it's so cumbersome to get it typed in the right way that just take the derivative of your derivative, and then you could turn both of those off and find your possible points of inflection and see sign changes and everything. Okay? Alright. So anyway, now we're gonna, usually a problem like this would be without a calculator though. And I've forgotten what all it asked. What did it ask on this thing? What are we doing? Are we doing max and min and points of inflection?
No, it was just the
Okay. Min and max. Oh, and it's a second derivative test or something. Okay. All right. So I think I probably was flying through my critical numbers. So if you're doing it on your calculator, you would say this. And if it had you would say 0 or undefined, okay? And then you could do calc intersect. But right now I'm going to say 2 cosine x minus 2 sine 2x is 2 sine x cosine x. And so that gives me 2 cosine x minus 4 sine x cosine x. Got to know your double angle identities. And then always state what you're working with also. I'm going to take out 2 cosine x. I think this is kind of where I was flying through the other day, and it leaves you this. Okay, so then I'm looking at, and this is something Caitlin and I talked about this morning. Real important. you're looking at where this is 0. No matter what you're doing, who you are, what your grade is in here, please listen to this. It's very important, okay? Don't divide both sides by 2 cosine x. Do y'all see you could like do that and you feel like, wait, I've done that before. You should never do that. And we've talked about that already because I know you responded to me. If you could divide by it, what could you have done in its stead? Factor. But I mean even like a -2 or a 7, if you're going to factor that, you need it for your plus minus chart. If you divide everything by -2 and then that negative is gone, it messes up your plus minus chart. So keep all your factors in play, okay? So now I'm looking at where cosine is 0. To move a little faster, that would be in this domain, pi over 2 and 3 pi over 2. See if this works better. And I'm looking to see where this is 0, which is pi over 6 and 5 pi over 6. Everybody okay so far? Double check that it's defined, but this is continuous and differentiable everywhere. Sine and cosine we know are continuous and differentiable, smooth transitions, smooth curves everywhere. Also, just something that popped in my mind, keep in mind the local linearity of this. If I zoom in on that enough, it's just going to eventually look like a line, and all of these are just going to look like little bricks that are laid next to each other to make that curve, locally linear. They merge for a second. Okay, so now I'm going to do a plus minus chart. So I'm going to do a first derivative chart from 0 to 2 pi. And I'm glad I'm going over this more slowly now. What's the first one that I come to is pi over 6. And then I come to pi over 2. No, 5 pi over 6 is next, isn't it? Yeah. 5 pi over 6 is in the second quadrant. And then pi over 2. And then 3 pi over 2. Thinking around my circle. All right, now from 0 to pi over 6.
It's pi over 2 first. Because 3 pi over 6 is pi over 2.
Oh, 5 pi over 6 is in the second quadrant. So, yeah, thank you. Pi over 2, then 5 pi over 6. Is that what y'all are saying?
Yeah.
Thank you. Okay, so anyway, from 0 to pi over 6, how are you going to know what happens? So I'm going to think of something before pi over 6, maybe, but we'll just see what happens. It's even hard to pick a number before pi over 6 and fill it into your derivative right here. Right now, I usually can pick something like pi over 4 or pi over 3, but right now it's even really hard to pick one. We technically could, we probably could pick 0 and be okay, because this one's not even 0 at 0. It just happens to be like a boundary, an endpoint. I usually don't pick 0, but let's do it and then we'll go forward from there. Cosine of 0 is 1, so that's positive. Sine of 0 is 0, so that gives me 1 here. So those are both positive. And so I feel like it's definitely positive here. If I think from 0 to 30 degrees, I think you're almost going to have to pick 0. It's really hard to think of something else to pick there. So let me show you what I'm talking about. If I'm doing a number line to pi over 2 and pi over 6 and pi over 2 and so on and so forth, this is a number line. It's only going to change signs, if at all, that it's critical numbers. And we really don't even know what the critical number was. Do you see how they just started this somewhere in there at 0? So 0 is in between a couple of critical numbers. Are y'all with me there? Okay. You probably could pull it off with some sort of just thinking about what cosine would be and what sine would be. This would be pretty difficult if I didn't have that. Let's move on. Something between pi over 6 and pi over 2 would be pi over 3. Okay? The cosine of pi over 3 is positive. Here I've got to think about the sine of pi over 3. The sine of pi over 3 is root 3 over 2. So I have 1 minus 2 times root 3 over 2. And you may not, square root of 3 is 1.732, but you at least know that that would give you a negative, I think. All of you know the square root of 3 is more than 1. So you have a positive times a negative, that gives you a negative. And then between pi over 2 and 5 pi over 6, I could use 2 pi over 3. The cosine in the second quadrant all of a sudden is negative. And the sign of 2 pi over 3 is the same as the sign of pi over 3. They're both positive. So it looks like I have a negative times a negative. Always be careful it doesn't have to alternate. All the way from 5 pi over 6 to 3 pi over 2, pi would be a good one to use. Are y'all okay with that?
Yeah.
So cosine of pi is -1. And the sine of pi is 0, so I have a negative times a positive. That gives me a negative. And then 3 pi over 2 to 2 pi, I could use like 11 pi over 6. The cosine of 11 pi over 6 in the fourth quadrant is positive. Sine of 11 pi over 6 is -1/2. So I have -2 times -1/2. That's definitely going to be a minus, a negative, another positive. And so I get a positive. So my function is increasing. This is my function. Increasing, decreasing, increasing, decreasing, increasing. Now, what I was going to say is I would say this one is increasing on the intervals 0 to pi over 6 and pi over 2 to 5 pi over 6 and 3 pi over 2 to 2 pi. Did y'all notice I bracketed in the endpoints because it's coming from somewhere else? It is definitely increasing like somewhere before 0, like that whole entire time. They just cut it off at some point. So that endpoint should be included because it's not a critical number. 0 and 2 pi is not leveling off 0, so it is actually increasing during that time frame. Questions, comments on that? My original thing that I thought when I went back to this problem is I would now go on and find points of inflection. And this should be a curvy graph, should find lots of points of inflection. And so I would take the second derivative, but I may bypass that because I feel like it'll come up in some other problems. I really want to lay the groundwork of that. Oh, I know, another thing I want to say I wasn't supposed to do that. Is that what somebody just raising their hand? Wasn't I supposed to use the second derivative test? Okay. Which all of a sudden I was going to make that point. I was going to go, I wouldn't want to do all of this. I would probably just want to do the second derivative test. But I think the second derivative, does it fail on one of them? Anyway, let's see. So I accidentally made this point, like that was a big pain. So sometimes you pick and choose, sometimes you have no choice. In fact, I would have to count off if you did what I just did. If I said use the second derivative test, and you use the first derivative test. The first derivative test is a plus minus chart on your critical numbers. The second derivative test is filling them into the second derivative. So I'm going to go in and take the second derivative. And so let's just pause for a minute. Suppose that this had just been a problem where you had free reign. And you took your first derivative, and you found all your critical numbers, and you know your maxes and mins and increasing, decreasing. Then they ask you for points of inflection. So now you have to do the second derivative, right? Concave up, and if they ask for concavity and stuff like that, you got to take the second derivative. So a lot of times I say these things and it doesn't make sense until it actually happens to you. But please take this for what it's worth. When you get ready to take the second derivative, you can take it from here, or from here. Please pull back from your problem and look at all your expressions for your first derivative and take the one that's the easiest for you. Like I don't really want to do a product rule. Do y'all see what I mean? Okay. Now I had to do that to get my critical numbers. Do y'all see I still had to do that to get my critical numbers? But I don't have to take the second derivative from this location. Okay? I'm going to take it from this location. So make it easy on yourself. -2 sine x. This one's going to be -2 cosine 2x times another 2. I believe that's it right there. Does that look right to everybody? Yes. All right, so now the second derivative test is I would start feeding in my critical numbers like pi over 6, pi over 2, 5 pi over 6. That says 5 pi over 6 and 3 pi over 2. All right, pi over 6 is, all you really need to know is the sign, so don't sweat over the number too much. But we know sine of pi over 6 is 1/2. The cosine of 2 times pi over 6, that's the cosine of pi over 3, which is also 1/2. And so I'm gonna get a negative number. So what does that mean pi over 6 is? So there's a relative maximum at x equals pi over 6, which I hope is what I had up here, okay? Then pi over 2, sine of pi over 2 is 0. And if I put pi over 2 in here, I get -4 times the cosine of pi, which is -1. So I get something that is greater than 0. And so you would have a minimum at this point, a relative minimum at pi over 2. But you see how you just fill them in. If one of them turns into 0, you gotta go back to a plus minus chart. That's why they say if possible. Here is an example that I would really rather do the second derivative test than the first derivative test. So as I was stumbling through that plus minus chart, I was thinking, why have I not stumbled through this before? I don't know, sometimes if you can tell my brain's sort of thinking about something else while I'm trying to talk to you, and I'm thinking, I've looked at this problem a lot, why haven't I ever thought about that little stretch between 0 and pi over 6? Because I can usually pull that off by picking something. I couldn't really see a way to know for sure. But at that point, I would stop and just go in and do the second derivative test. Does that make sense?
Yeah.
Okay. So use the second derivative test when it's convenient unless someone tells you otherwise. Second derivatives can tell you a lot. They can tell you concavity, points of inflection. I'll even show you they can tell you things about increasing and decreasing. Don't worry about that now. That's for you exclusively first derivative. But your critical points can be tested by the first derivative test, which is a plus minus chart, or the second derivative test, which is a fill-in. Okay? All right, let's go on to, in the worksheet. I think I wanted to just go on and do number 5. Yeah, so number 5, which I think I have the whole thing already in this slide. Oh, well, that's not what I really wanted to do. I was trying to copy this, and I copied the whole picture. Okay, so we're doing this, and I've gone over this with a couple of people enough to where I felt like I should do it in class. All right, so you'll have stuff like this that just seems kind of vague, pie in the sky stuff. Write an equation of the tangent line. This is where somebody has walked up with a silver platter and drawn here, okay? If you know what you're doing. If you don't know what you're doing, it'll show up in a hurry anyway. All right, so you're like, okay, thanks a lot. So on A, I'm going to tell them I know what I'm thinking. F prime of -1 is -3, and I have the point -1, 2. Since it's a free response. So I would go y minus y equals m times x minus x, done. Make sure that doesn't look like a 7. All right, then B just takes confidence. They gave me g prime of x, and they said, does it have a local maximum or minimum at x equals -1? Justify your answer. Well, I decided to do the second derivative test here. I don't even know if I could do the first derivative plus minus chart, even though they handed me the first derivative. So have some confidence. That's why I tell y'all to be very literal. We should write it on the board every day I walk in here. You can take that second derivative. It's really ugly, but those of you that have done it, it's not bad. So I'm going to say first, there's a big lesson, a lot of lessons in everything I'm doing today, other than how I started class. That was a lesson on how not to do it. First, derivative of the second. This would be a coefficient of 3. The derivative of f of x is f prime of x plus 2, and then f double prime of x. Now I am thinking about the chain rule here, girls. The derivative of f of x, if that had been f of 3x, do you see I'd have to come back behind it and multiply it by a 3?
Yes.
So I'm saying the derivative of f prime of x, and then the derivative of x is just 1. Then I have plus the second, times the derivative of the first, which is 4x cubed.
Oh,
Sorry,
no.
it's okay, it's alright. There's an undo
Oh
button.
my god, I remember when my elementary school was like
That was
slowly
so
revealed.
Alright, so I have 4x cubed minus 18x squared. Now, hello, if I had a megaphone, I would like shout into the megaphone. Do not foil that out, start distributing, just start filling in -1. Do y'all see? I'm gonna put it in its purest form. I did first times derivative second plus second times derivative first. Girls, you'll find yourself doing this sometimes. You cleaned it up and then filled in like 3. You could have filled in 3 at the very beginning and not had to like clean it up, okay? Cleaning it up, what I mean by that is simplifying your derivative is if you only have variables in your answer choices. If you have numbers in your answer choices, most likely you should fill it in right away. Fill in your x and your y if you need to. All right, so now I need g double prime of -1. I guess the most aggravating thing in the world would be if I filled this in and got 0, then I would have had to go back and do a first derivative test. -1 to the 4th is 1 plus 6, -1 cubed. 3 times f prime of -1 was -3. Plus 2, f double prime of -1 is 5. And notice that my AP reader can grade this because I'm telling them exactly what I'm doing. All right, then this is plus 3 times f of -1 was -2.
Ow. Oh.
Or was 2. Okay, and 2 times f prime of -1 was -3, and I don't even care what's back here because this just zeroed out. Do y'all see that?
Yes.
Okay, that just went away. And this is 7 times 1, which is greater than 0. So there's a relative maximum at x equals -1. Because your second derivative was greater than 0. And do you see me hesitate? I'm like, greater than 0 to me feels like a max. Greater than 0 means that, oh, I'm sorry, did I miss that? Greater than 0 feels like a max, but this should be a what? Min, because it's concave up, relative min. And I hadn't worked these in a while. Is that what the answers had?
Yeah.
Okay. All right, other things from the worksheet. There's a couple I want to work, but is there anything else? There was one that you estimated some things that may have been a bit aggravating.
Oh yeah.
They're gonna probably get presented to you in a way where you're actually going from number to number that hits a corner. Hopefully you looked at the answer choices. A lot of people are doing what you should do because you can't get over every problem in class. A whole lot, probably about half the classes, come in by a quick question like, I don't know why this is working. A bunch of people I've talked to. So if I haven't talked to you, I guess you're doing fine and you understand what you're doing. A lot of people come by for like 3 minutes and they're like, I don't understand this problem. Like Caitlin this morning was like, I'm not getting the answer in the back of the book. And I think in 30 seconds we were done and I was over at my desk working and she was keeping on going. So, and it was really just a Miss Lazarian mistake. 12 divided by 6 is not 6. But, or you could be like Morgan and Anna and just live at Math Center and get home everything. Okay, so, but really a lot of you, I'm sorry, I shouldn't have started naming names. So many of you are good about coming in and out, and some of you don't need me at all, and that's fine too. I'm used to that. I'm used to that, and you probably see it. You may never need me. Are there any other specific questions on the worksheet? You're supposed to be starring, highlighting, so that when girls listen. When this day comes, you want to go, oh gosh, I can now ask these questions that have been building up on my homework. So every time you're doing a homework, you have a question, highlight it, star it, get your own system. Because when the day finally comes, they go, what are your questions? You want to be able to rattle them off. Is there anything else on the worksheet that I need to go over with you?
Not on the worksheet.
Okay, then we're going to homework next.
Yeah.
Okay, can I move on?
Yeah.
Okay, let's go to homework. I have 2 problems that I want to do fully that came up this morning in the Math Center. And then I probably will answer a lot of your questions, but I'll hopefully have a chance to, get to everything that you need. Alright, there was one that was x squared over x squared plus 9. What number is that?
35. X squared minus 9.
35. 35?
Yeah,
Alright, I'm going to 35. Don't overdo the problem. I'm going to overdo the problem on purpose. I know that you need to check me on that and go, stop, Miss Larry, if I'm like carrying on about something. Because I don't think it asks for points of inflection here and concavity. I think 35 just asks for max and min, maybe, okay. But I'm gonna carry on through the whole thing, okay? I'm gonna act like this is a free response that's find the first derivative or show that the first derivative is blah. You know, relative max and min, and then points of inflection and concavity. Even though it didn't ask me to. So y'all make sure that I have the problem right once again. Is that correct?
Yes.
Okay, so let's shrink the volleyball players. I have plenty of room to write. Shrinking the volleyball players. Okay. Little bitty volleyball players. We'll make them tiny. I feel like Vector and Despicable Me. Okay, y'all know that when he like shrinks the moon? So.
I wish I could shrink Morgan. And then I could have her in my pocket.
In your
She
pocket.
gets annoying. Just like put her in a hole.
You can just squeeze it.
Okay, so anyway.
If she could be like my ear.
How are you saying?
Morgan on your
ear
ear.
all the time?
We all have
We're
ears.
so weird.
Then you can clone her and we can all have Morgan earrings. Alright, so anyway, I'm gonna see if there's anything I can do to simplify that. If it was upside down, I would go on and make it like this. And avoid I'm not always actively trying to avoid the quotient rule, but if that's upside down, that's easily enough just divide it into a couple of fractions. Do y'all see what I mean? Alright, but it's not upside down, so I've got to do the quotient rule. So I'm going to say low, D high, minus high, D low, over low low. Now, this is one of those things I've warned you about, but until it happens to you, it might not have sunk in, okay? If now you start to multiply all of that out to find your critical numbers, life gets pretty ugly really fast. And then the second derivative, it gets really ugly really fast. I've never told you to multiply anything out. I've said this should be going in your head. Negative exponent, common denominator, factor. It feels funny because your whole life has been a drive in mathematics to foil things. I don't want you to. Because you're gonna need, I've known this day was coming. Where I keep telling you to factor, because I knew you would need your critical numbers and your points of inflection, okay? So why in the world would you multiply it out, even though you've been trained to, even though some people will tell you to? Don't multiply it out. Okay, so here's my list. Do I have any negative exponents? No, I bypassed that first step, but that would be your first step. Common denominator, I already have one. So next I'm at my third word, factor. What does this have in common? 2x. Alright, if I take a 2x out of the front, it leaves me x squared minus 9. And if I take a 2x out of the back, and if you didn't do this, isn't this nice? It's wonderful, okay? So I know my first derivative is negative 18x over x squared minus 9 squared.
Negative 18x.
Thank you.
Thank you.
Okay, girls, don't multiply the bottom out for like 1,000 different reasons, okay? I mean, there's probably really three,
Oh, the
but
bottom out?
do not multiply the bottom out. You wanna wait and see if something factors, plus something that's already factored is your friend. By the way, when I talk about your friends,
In my notebook.
it looks like right now my critical numbers, always, it's not just what makes your first derivative 0, but it's also what makes it undefined. Don't forget that you also want to see these like things that could be cusp for 20 points. That can happen. I've shown you some. However, watch what I'm going to do. Okay? I'm not gonna include them in my answer, but I am gonna include it in all my charts, okay? Now, the instructions on this problem, did it say to use the second derivative test, or did it just leave it up to us? Like find max, I think it just left it up to us. Max and min, increasing, decreasing.
Yeah.
Here's a case in point, y'all. I would do a plus minus chart on this. I would do given a choice, don't want to take the second derivative. I don't want to do another quotient rule. So do you see I would not do the second derivative test here?
Yes.
I would choose the first derivative test. It all depends on how easy, pick the easiest one, okay? So I'm gonna do a plus minus chart. I do need to include the 3 and the -3, but I'm gonna keep a constant reminder to myself, don't name them anything. They are asymptotes. Be aware of your domain from the beginning. A number before -3, like -4, the top would be positive and the bottom's always positive. Between -3 and 0, like -1, the same thing happens, and then it goes negative, negative if you're careful. I hope I'm right, okay?
Yeah.
So this is weird. This function increases, increases, decreases, decreases. In multiple choice, don't pick it increases from -infinity to 0. There's an asymptote in your head, okay? So it's not
I was
totally
like, why not?
You see what I mean? Let's start to look at the graph. There's an asymptote at 3 and at -3. 0 is a maximum. I would write out 0 is a maximum because my first derivative is 0, establishes a candidate first, and my first derivative, not it. You say my first derivative changed, you say f prime changed from positive to negative. You got to get both of those things in, okay? I have asymptotes. If I fill 0 into the top, I get 0. I know before 0 it increases, and after 0 it decreases. And I believe this part, if I found a few more points, would look like this. By the way, it's going to come up later today. This is also an even graph, if you can verify with me. F of x equals f of -x. Does everybody in the room know what I just said?
Yes.
Okay. So what that means is it doesn't matter if I go this direction or this direction. That's what f of x equals f of -x means. You're going to get the same value. It's even. So I can graph it a little faster in case you wondered why anybody cared about even, odd, and either. Does everybody see now? I wouldn't say that it increases from -infinity to 0 because it's doing this. So I would say it's increasing from -infinity to 3, open parentheses, and then it's increasing on the interval from 3 to 0, parentheses. Did y'all see what I mean? Okay. So we're done with that. Now suppose that they asked me about concavity and points of inflection on the C part. All right, so I'm going to take my second derivative, which lesson number 1, it's best just to go slow the first time. A couple of people could tell you that was watching, that, you know, I wrote it on the board 3 times and got so mad at it, I finally just sat down at my desk and just calmly did it, okay? Also, I was so mad at it because it wasn't in the book, there wasn't like an answer, it just didn't feel right to me. So I went to a second derivative calculator online just to see what is it, so I can know what I'm doing wrong. So you can do that. I have a few links, or you can just Google second derivative calculator. Symbolab's really good, and it'll even show you the steps sometimes. So anyway, I'm gonna see if there's anything I can reduce. I'm gonna go low, D high, minus high, D low, chain rule 2 times x squared minus 9 to the first times the derivative of the inside, which is 2x. I guess that's good. Over low, low. I can't tell you how many times in my life, much less this morning, I forget to square the bottom and I just write down x minus 9 squared.
It's already.
It's already squared, and I just like tricks.
I did that too.
I
I
do
did
that a lot.
that, and then I also at one point left out the parentheses, so it was like x squared minus.
At one point, I distributed.
Okay,
Exponent.
yes.
Oil.
Okay, girls, I've seen people multiply, my students multiply all that out. Don't do that, you can factor it again. Plus, you're just making your life miserable, okay? So calmly factor out what's in common. I was trying to do it too fast this morning. It's best to just, haste makes waste. So let's just calmly factor out what's in common. You're gonna go through your rules, negative exponent, you plop it down underneath whatever it's attached to, maybe not all the way to the bottom, it just hinges underneath. whatever it's attached to, then you might have to multiply by a common denominator, and then you factor. Right now, we're at the point where we're gonna factor. These both have a negative 18 in them, and an x squared minus 9. And this is where I just went too fast. The negative 18 is gone. I can't really cancel it, but it's out there. I'm sorry, I'll come back. And there's an x squared minus 9 in here, okay? This minus sign's real important, but I took out this negative 18 and this x squared minus 9, okay? And so I have minus 2x, and 2x is 4x squared over x squared minus 9 to the 4th. So all of this method is really, really helpful and really helps your problem. Now this is negative 18 times negative 3x squared minus 9 over x squared minus 9 to the 3rd, because this cancels because it was multiplied. As long as I'm doing this, I might just well factor out this negative 3, but before I go on, let me say if I'm gonna do in a minute a plus minus chart, and I'm gonna look for points of inflection and see what makes it 0. This is another case in point where when I do set this equal to 0, I don't want to divide that negative 18 out. Do you see that negative 18 is changing the sign? It's involved in the problem. Please don't get rid of it, okay? When you factor something out, keep up with it. I'm going to go in and factor out a negative 3 though, and it makes it look a little better. So if I factor out a negative 3, that becomes 54 times x squared plus 9 plus 3 over x squared minus 9 cubed. Okay, so I don't even get any critical numbers from the top. This is a super good problem. Okay, I'm glad that nothing Morgan had like gone further than they asked her to, because it made me realize this is a great problem to work together. X squared plus 3 doesn't, that can't ever equal 0, can it? So my only PPIs or pips, my only, why am I not calling points of inflection for 1,000 different reasons, really too, is I hadn't tested them yet for a sign change, so don't you call it anything, okay? Don't just go, oh. Also, 3 and negative 3 aren't even part of this problem, okay? Those are my only possibilities. So I'm still gonna put them in a chart, in a second derivative chart. I'm gonna put in negative 3 and positive 3 because they're the only candidates. I'm gonna cross them out, but I still wanna do the chart with them. They need to be in the chart. They are impacting your problem. Before negative 3, like negative 4, that's all positive over positive, okay? In between here, like 0, that's positive and that's negative. And then I think it goes back to positive. That means that my original function is concave up, concave down, concave up. Big, huge deal. You cannot call negative 3 and positive 3 a point of inflection, though they're not even a point. It's really hard to be a point of inflection if you're not a point. So do you see how much you need to be aware of? I can talk about concavity, but I can't talk about points of inflection. If I scroll back up, do you remember my graph indeed goes concave up, concave down, concave up?
Yeah.
It does help me with my maximum that landed right in here when my derivative was 0 and my second derivative is negative. I want to show you something else this shows you. Y prime, okay? Let me get a different color. If this is Y prime, then this is Y prime's derivative, right? So I said I was going to show you this later. So you also can scale back and forth from, there's 3 functions you've got to know about, your original, your first, and second derivative. They could give you any of them, and you've got to go from one to the other fluidly or carefully or whatever. While the derivative of something is positive, what would this thing be doing? Your derivative would be increasing, okay? While the derivative of your derivative is negative, your slope should be decreasing and then increasing, what Elena said, okay? Now let's look back up at the graph. You may be asked to say that. In fact, girls, coming soon, you'll know that the second derivative is positive. And I'll ask you, why do you information they gave you, your first derivative is increasing. So what does that mean your second derivative is? Positive. Did y'all see? So, but your reason would actually be because what you gave me is increasing, not just my second derivative is positive. I know it because of that. That's just a little window into what's coming. Would y'all agree that your slopes are increasing? Now, are my slopes really decreasing? 2, 1, 1/2, 0, -1/2, those are decreasing, aren't they? If I wrote them in a list. So y'all see how that works? Okay. All right, so that's a beautiful problem. All right, what was, okay, question?
So does that mean that with the second derivative test, you can find out if like a function's increasing or decreasing?
You can find out a lot going
So,
back
like,
and forth.
You technically, if the question was just like, is this function increasing or decreasing, you could just do a second derivative test instead of the first derivative test.
Okay, now I haven't said the function's increasing.
Okay.
I've said the slopes
Oh, okay.
are increasing,
That
okay?
makes sense.
So I haven't really said anything about the original other than concavity yet. Doesn't mean that I can't, but I think I've probably exhausted what I need to do with this problem before I confuse you, okay? A lot of good, I hope that that really hit home about like how to handle the derivative. Let me tell you something I've told a few people. These two or 3 problems I'm working at the beginning of class today are like, oh my God, well, how am I ever gonna finish my AP exam or your test that's coming up, okay? They only ask a couple of these, maybe 2, that are just this treacherous, dogged, endurance, careful derivatives to see if you really can do it. But you also see that a whole lot of the tests are finding out if you know calculus. They'll just say, here's the second derivative, what are your points of inflection, okay? So there's a lot you can just knock out. This isn't gonna make or break your test, but you'll see now as we get closer to the end of first semester and into second semester, you should get really tired and going, there's not a lot of this on the exam, this isn't gonna make or break your 5. But those could add up if you don't know each one. Do y'all see what I mean?
Yeah.
Okay? So you almost ought to discount it when I say that. All right, now what number am I going to? Morgan, what was the other one that we were looking at? 11?
That's the one you said you wanted to do.
All right, so I said I wanted to do 11
On 195.
on 195. So this is 11 on 195. I forgot why I wanted to do it, but we'll see.
Another one of those. 11 and 15 are kind of like 15.
Okay.
15.
Do 15 instead of 11?
Yes.
What is 15? Let me see if it sounds good.
G of x equals x squared plus 4 divided by, oh, I wrote it a little.
Over 4 minus x squared.
Seriously, is that what it says? What number is it?
Probably
15.
15. All right, so read it again.
X squared
X
plus
squared.
4.
Yeah.
Oh, plus 4. Okay.
Over 4 minus x squared.
Okay, I'm sorry. The reason I was like, is that what it said? It's because that would equal -1 if it was x squared minus 4 over 4 minus x squared with a couple of holes in it. That 2 is -2. So its derivatives would be 0. The second derivative would be 0. So that would have been delightful.
Like Caroline.
This looks worth doing. I just hope I don't mess it up. I've already worked so, somebody go in and pull up, type Google second derivative calculator, if you would, Sophia. And, Sophia's, and, there'll be a symbol lab, I think, that comes up. So go to that one. Or if anybody gets it, that's fine. It looks kind of, that, yeah. Okay, now, if you would type that function in and hit calculator enter or whatever. Don't tell me what it is yet. Okay, so first derivative.
Wait, no, that is the first derivative.
So
you do first.
Oh, I'm sorry. I don't know what 15 and
Didn't
that's
they give
mean.
it, isn't that already the first derivative?
That's the first derivative.
That's the first derivative of the function.
No,
that's the function.
So why do I have it written down?
Oh, let me check. We can read the book around.
Maybe you messed up.
Maybe that's why I was getting like plus minus 4 on the square root of 4 over 3. And I was like, well, I got the square root of -4.
Page 1.
95.
Yeah.
No, it's the regular.
Okay, 195, number 15
Well, then I
is
did it wrong.
determined
Maybe that's why I
the,
couldn't get the answer.
we gotta get concavity and they gave us the original. So maybe that's why I did it right. This is the original. Girls, play.
Yeah, that makes
might be good to make a note to self that 2 and negative 2 cannot be part of this problem. I think it's a good idea to be aware of from the beginning. However, I want to include them in any chart that they pop up on. I don't know when the last time I worked this problem, if ever. A lot of times I just assign them and think, oh, I can do that. Okay, so keep an eye on what I'm doing. I would first look and see if I can reduce it, but I can't. So now I'm going to take the first derivative telling my reader what I'm doing. Low D high minus high D low over low low. Okay? Now I'm not going to multiply all of that out. Here, honestly, it wouldn't be the worst thing in the world, but I don't want you doing that unless there's just, if there's nothing you can factor out, then start multiplying things out, okay? But what do you see that I can factor out of this?
2x.
Why don't we, 2x. Alright, so if I factor out 2x, that leaves me 4 minus x squared. I gotta be real careful with this negative. I think, if I took out a 2x, that leaves me a negative and a negative. Is that gonna give me minus x squared minus,
No, that would give you positive.
Yeah.
that was right?
Yes.
Okay.
Yes.
Over 4 minus
But
x
it's so
squared
pretty.
squared.
It looks so
So
good.
this-
Why is it pretty? Because it cancels out.
It cancels out and I
It's
get
also nice.
16x. Here's what
I
just
like numbers like that.
makes me
Good to know.
so
Why did I
excited.
not get them?
This problem didn't have zero anywhere on my radar.
So excited.
Look at the original problem. X squared plus 4 over 4 minus x squared. Isn't calculus beautiful? I took the first derivative and all of a sudden 0 stands out from all of the numbers in the whole wide world. If it's 1/3 or 7/4 or 85, it's gonna pop out in your first derivative. It's super cool. I got goosebumps. Okay, so anyway, critical numbers are 0, 2, and negative 2. Well, at least you know I'm passionate about my subject, so I get to do something else
I
every
love
day,
it.
even though it's kind of
Nice.
weird. All right, I am gonna put those in my plus minus chart. But I'll come back to that. They didn't ask me any of that, so when you model what you should do, all they asked me here is concave up and concave down. So I'm not even supposed to find maxes and mins. So I will not necessarily take the second derivative from here. I'm gonna step back and look at all of my first derivative work and take it from the easiest spot. And the first time I said this today, I think I took it from the first spot, not like the third or fourth work. And this one, why don't you just go in and do it from your last spot, from your last piece of work. All right, so my second derivative is low D high minus high D low
Which one?
over, and I'm gonna remember to say the bottom squared this
I
time.
feel like I couldn't.
All right, these have,
I didn't know that.
what do they have in common?
4 minus x.
How about 16 and a 4 minus x squared?
Yeah.
Okay, I took out the 16 and it leaves me a 4 minus x squared here. Negatives are going to be our biggest issue. I took out a 16 and a 4 minus x squared. Is that right? So that leaves me a 2x and a negative 2x behind a negative sign. Is that right?
Yeah.
Over 4 minus x squared to the 4th with a big long line after it. All right, so now I have 16 times 4 minus x squared. Oh no, let's go
No,
ahead
you
and
can take
cancel
that
that. Okay. This gives me 4 plus 3x squared over 4 minus x squared to the 3rd. Okay, 4 plus 3x squared does not give me any PPIs, possible points of inflection. I cannot make that 0, the sum of squares, okay? But it would have been cool had some shown up that we weren't expecting. All these numbers will show up. So, my possible points of inflection, I don't even have any, But I am gonna make a chart with -2 and +2, reminding myself I can't call them anything, but I still need them to test for concavity. So now I'm gonna fill in a number like -3, the top will be positive, and -3, the bottom will be negative. Are y'all okay with that? Does that seem right to you? If I put in a number between like 0, the top is positive, and the bottom's positive. And then after 2, I suspect it goes back to negative, because the bottom will be negative. All right, so I can say that this one is concave down from -infinity to -2, and from 2 to infinity, and is concave up from -2 to 2. Is that the answer in the back? Okay, and no points of inflection. Okay, they're asymptotes. It'd be similar probably to the, it must look something like this. Concave down, concave up, concave down. Grace?
Can we like use like the union sign?
Yeah, you can. I just am not really good at those intersection union things, so I just leave them out.
I agree.
But I think union is the correct thing. I say it's, I don't like it though, because it's really an or. It can be this or this, and to me, it's like it's,
One of them is and, one of them is
but that technically means they overlap, which
No,
means
Or is
they're
multiply
so-
and is
but you can't.
Okay, I don't know, is it up? Is the up?
Okay,
This one is 4.
No, that one's and. No, this
I
is
actually don't remember
Guys,
ever
I
seeing the upside down.
The rainbow is
The
and.
The
union
union.
The union or
Yeah, the
or.
But yeah,
Yeah.
the union
When I said
isn't
union, I
technically
think
or.
because it's like,
Your unions,
it
yeah.
could
Is
be
it
both of
and
them,
is,
or it's like,
and is
whatever,
add
like both
multiplies
power.
or?
I know, I don't really like it, so I'll leave it out.
This is so
Hey
funny.
girls,
So
listen,
the end
let's
is
circle
like-
back, 'cause we're having a great class so far. Listen, thank you. Great, boring class, but it's a great class. A lot of good things happening. What was I gonna say? I don't remember ever seeing that intersection sign on the AP exam or multiple choice or anything though, so I don't think it's gonna come up. But you could definitely, I think it's more common to write it. In the back, they probably did that little union symbol. Okay? All right, so, Caroline, I think you were suggesting
I
that.
have no idea what I did wrong,
Okay.
but I got the exact same answer, but my derivative is different. I don't know if that exists.
And did I get the correct derivative?
Yeah.
Symbol, okay.
Yeah.
Now, what was that one that there was one I was so excited about that these points of inflection just flew into the problem I wasn't expecting. That might be on number 11. I think it is. So I'm gonna fast do number 11, okay? This is number 11 and I'll show you why I'm doing it. So on number 11, it's like it's not great. Oh, there it is.
Do you think they can have 5P?
No.
All right. So we have y.
Without you?
Y is equal to
Without
24 over x squared plus 12. This domain is all real numbers. The domain's all real numbers, so everything's like fair game as it pops up. I'm gonna go low, d high, minus high, d low, over low, low. So that gives me negative 48x over x squared plus 12 squared. It's really cool that my critical number of 0 pops up. It looks to me it would be positive and then negative, and it would be a maximum if I did a plus minus term, okay? I'm gonna go on into the second derivative, but again, 0 is not on our radar. And I believe 2 and negative 2 are about to pop into our radar. They're gonna start just popping out at us from our test. So I'm gonna go low, d high, minus high, d low, over low, low. So I have let's take out negative 48 and x squared plus 12. Alright, for those does anybody listen to me? I'm turning around trying to talk to myself. So I'm taking out negative 48 and an x squared plus 12. So it leaves me x squared plus 12. I took out this negative 48 and this x squared plus. So I have another one of those minus 4x squareds, I think. That's happening a lot today. That's kind of weird. Alright, over x squared plus 12 to the 4th. So my second derivative is negative 48, which I need, times 12 minus 3x squared over x squared plus 12 to the 3rd. Girls, I can factor a 3 out of that, or a negative 3, whichever one you want. Let's factor out a negative 3. 48 times 3, I think is 144. So if I factor out a negative 3, it switches this around to x squared minus 4. To me, again, this is so cool. Do you see how at the beginning of the problem, there were really no numbers that popped out at me? There was nothing that was phenomenal about this problem. It's to find for all real numbers, but nothing seems important. Nothing makes it 0, okay? But I got a critical number of 0, and all of a sudden these cute little points of inflection pop up. My possible points of inflections, my pips, are 2 and negative 2, but don't call them anything until you test them. If I put in a number like negative 3, that's positive. If I put in a number like 0, it's negative. So I would say, yes, these are points of inflection because they made my second derivative 0, and because I see a sign change in my second derivative at those numbers, okay? So now, this graph should be concave up, concave down, concave up with a maximum during this time that is concave down at 0. Let's look at the graph of it real quick. I'm not going to fight with my graphing calculator. I'm just going to go into Desmos because I don't like fighting with the graphing calculator sometimes, but it's really cool to see this happen. What we talk about hidden behavior. If I put in my function, what did I start with?
24 over x squared plus 12.
Don't want to take another standardized. No, I can take December.
Beginning of the month.
Yeah. No, then they'll pay off.
So
And then I can submit them for June.
I've seen it a lot more subtle than this, but at negative 2, if I couldn't even see the rest of the graph, do y'all see at negative 2 how that graph is concave up?
Yes.
Okay. If I look at it between negative 2 and positive 2, all you see is concave down. And then concave up. Okay. I haven't done much of it where something failed the first derivative test and went on to win the point of inflection award. Okay. But right now, I mean, that could happen. So it doesn't always have to happen. Also, it's not surprising, so don't be surprised if you feel like, well, my point of inflection has happened right in the middle of something like if you're looking at, it happens right in the middle sometimes of an evenly dispersed graph. Any other homework questions? Okay, Grace?
It's not about the homework. I have
Okay.
a question about the quiz. Are we gonna have calculators or no calculators?
I will, send you something to study, or have you studied this? I'll be deciding, and I'll be really clear when I post the assignment, which will be, I have lunch and then I'm off. I have a free before the next, so it'll be posted before, sometime in the next hour.
Okay.
So I'll look back and see what quizzes I've given on derivatives before. I'm kinda thinking that you'll have a calculator, but it's not gonna make a difference on the non-calculator active problems anyway. I don't see how a calculator would help me on these problems back here, unless I just typed it in and did the whole thing on it. Alright, so, right now I'm not telling you to do anything on these. I wanna talk about the first problem with the last 3 minutes that I have. Like I was telling Grace, there's maybe something I'll tell you to do with this. It may become your homework, it may become your study sheet for the quiz. These are just great problems on everything that we've learned so far. And I know you are hungry for new responses. Who was absent? Oh,
Rose.
all right, so, all right, look at number 1. I'm sorry it's so small. I'll get it really big up here. The other pages I did copy better than that one. It's this one, isn't it? This is from 1991, which again, in the AP calculus scheme of things, is very, very recent. I love this problem. I usually put it on a test, so small possibility you'll see it again. Hopefully this year. Remember, I just did it in class, but I may like it anyway. I love this problem. All right, notice how they've underlined this word even, okay? But look, girls, this is continuous. It didn't say it's differential. It's continuous from -3 to 3. But your table values only go from 0 to 3. Okay? But
It's
we're
even.
gonna, it's even. Okay?
Oh my gosh.
But you still gotta stop and think about what's happening if it's even. Alright, so find the x-coordinate of each, oh, by the way, they may have said here, instead of even, they may have said f of x equals f of negative x, and you write above that to yourself, note to self is even. But they say f of negative x equals negative f of x, and it's odd, okay? One big thing about this is if this is even, its derivative is odd, and then haven't I told y'all that it rotates back and forth, which will help you with your charts. Okay, it's doing the opposite on the other side if it's odd. All right, so now let's think about a first derivative chart. All right, my first derivative is undefined at 0. So that's important, and I do include this in my talk because it's continuous everywhere. The domain of this is all real numbers, so it is important to know that my first derivative is undefined at 0. My first derivative is 0 at 1, and undefined again at 2. Sometimes I circle these to remind myself that those will be pointy points. If it's undefined, if the derivative is undefined, but the point is defined, those will be real sharp turns. It will not be a smooth transition, so you need to reflect that in your graph. All right, so now let's go backwards. This stops at 3, and now I'm going to go to -3. So what should happen at -1 and at 2 if it's even?
0.
-1 should be 0, and -2 should also be a critical number. Do y'all see that?
Yeah.
Okay. Now, while my first derivative is negative between 0 and 1, what would my first, we'll just do this, That's unfortunate. What I was, did y'all see I was about to mess up the chart? It should go negative, negative, positive. You gotta think about, oh wait, my first derivative is odd, so think about what that would mean on the other side, okay? So if it's negative, negative, positive, and it's odd, what would it go in the other direction? You've got to go in the other direction like this. So think about that, and I will post which numbers to do. Most likely I'll have you do a couple of these for homework and study for the quiz, okay? And test, oh, so you have a long time for the quiz, because it's Monday, and then test on Wednesday.